Good afternoon, sir. Myself, Animesh Barnyal, roll number 194105, and I'm here to present the project on behalf of our team. The topic of our project is text to speech conversion using deep learning. So, our team consists of four individuals: Tanuj Kumar, roll number 194115, Virender Saini, roll number 194113, Ritesh Pushkar, roll number 194114, and Animesh Barnyal, roll number 194105. So the first thing I'd like to present is why did we choose this project? So the major reasons to opt this project was number one, the text to speech technology is currently one of the fastest growing technologies in the current generation. This technology can now further be used to facilitate the local regions around us. Text to speech can be of significant use for the people who are struggling to read, and the text to speech technology is known for reading out digital texts and words of computers, smartphones, and tablets, which can help people who have difficulty in visually. So, the next thing I'd like to present is the general pipeline that we have used for the text to speech conversion. So, the first thing we do is that we take the input text and pass it through a text preprocessor. This text preprocessor then converts it into character tokens, which are processed by a model. The model we have currently used is Tegatron 2, but we can also use another model by the name of fast speech. So what this model does is it converts these character tokens into a spectrogram. So a spectrogram is a collection of frequencies of varying range which helps us to convert it into a audio output. So this spectrogram is then passed on to a vocoder which will convert it into an audio output. So I'd like to shed some light on the text processing part. So the phoneme based encoding which we are using in this model is similar to character based encoding, but here we use symbol tables based on phonemes. So the library that we are using for this is Deep Phonemizer, which is present in Torch Audio. The models that we are using are Tegatron 2 model. uh, we have studied that we can also use the fast speech model, but further study needs to be done on that. The difference between the Tegatron and fast speech model is that Tegatron model converts it into a spectrogram, and then we have to use a vocoder to convert it into audio output. Whereas in the fast to speech model, the spectrogram and the waveforms are produced simultaneously. So about the future scope, what we aim to do in the near future is we need to code out the discussed models in the spec to get the spectrograms. We have already made a prototype for the Tegatron model, but we aim to do the same for the fast speech one. And the second thing is do the time domain conversion of the achieved spectrogram for the fast speech model. So I'd like to present the prototype that we have generated. So this is the project that we have created for now. This is a very short prototype model. First thing we do is importing all the required libraries. The libraries that we have used are Torch Audio, and for the backend of output generation we have used Soundfile. Now uh, as I present it, I am going to run it in the background. So after importing, what we do is we take all the required references to the processor, the model, as well as the vocoder. Then we take in the text input. Let us type the text input as testing code. After that, we use it and generate the tokens, which are done by text processor. Those tokens are then passed on to the Tegatron model, which creates the spectrogram. And after the spectrogram generation, we pass it on to the vocoder, which will now give us the audio output. This process seems to take a little bit of time, so I'll try to speed it up. Yeah, so here it is.
Testing code.
So it seems to have run. The vocoder that we have used in this prototype is Wave RNN, but there are other two more vocoders, one supported by NVIDIA by the name of Waveflow and another one by the name of Grifflin. In the future, we aim to use all the three and test which one has the best output. Thank you, sir. That was all I had to present. Now, as for the individual contributions are concerned, Animesh Bernial and Tanuj Kumar, roll number 194105 and 194115 respectively, are responsible for the understanding, execution, and compilation of the code on Jupyter Notebook. Virender Sani, roll number 194113, and Ritesh Pushkar, roll number 194114, are responsible for the compilation and the writing down of the project report. Animesh Bernial, roll number 194105, was responsible for the presentation creation, and the understanding and development of all the concepts was done by all the individuals. Thank you, sir.